Kia ora Year 9. This video is for Noah and it's looking at linear patterns. So first we're going to look at how we go from a pattern to putting some information into a table. Then we're going to work out the rule for that pattern and we might look at graphing if we've got time. So this is from a worksheet that Miss Zhang has made that I've shared on our Google Classroom. I've put solutions up as well, but if you want to see how I got them in more detail, then you should watch this. So we're starting out with a pattern of squares, right? It's a pretty boring pattern. It's just a bunch of squares, but it's got some mathematical structure in it. And if we look at what we've got here, we can see that in pattern 1, we've got 3 squares. In the next one, we've got those 3 squares, and then we've got 2 extra. In the next one, we've got those 3 squares, these 2 extra here, and I just want to change pen colour, and then I've got 2 more. So every time it's going up by 2, and that's going to be the key to figuring out what's going on. So when I get a patterning problem, I start out like this. I say, what's my pattern number? Well, here's the first one, here's the second one, and here's the third one. And then I look at what I'm asked to find, and in this case it's not lines or anything complicated, it's just the number of squares. So this one's got 3 squares, this one's got 5, and this one's got 7. But it's nicer to put that information into a table. When we work systematically, we're much more likely to see the pattern. So here's my table, and I can see that the first one had 3 squares, and then 5, and then 7. So we look at what it's going up by. Every time we're adding on 2. So a common difference is 2, right? It's going up by 2 squares each time. So we have to now find the rule for this pattern. And this table's got a whole lot of weird stuff in it, so it's got lots of gaps. Right, so first we figured out patterns 1, 2 and 3. Now we're being asked to figure out how many squares would be in patterns 4 and 5. I can do that by drawing it, and I'm going to draw out pattern 4. So pattern 4 would have a square here, then 2 squares there, 2 more there, 2 more there, and 2 more there. Because pattern 3 has got 3 rows like that, and that 1 left over. Okay, so that's what pattern 4 would look like. But we don't really need to draw them all out to see what's going on. We know it's going up in 2, so pattern 4 would have 9, and pattern 5 would have 11. This is called finding the next term in the pattern. Right? So now we're asked to figure out, what about the 11th pattern number? Right? So n is 11. That means find out how many squares in the 11th pattern. To do that, what I want to do is to find the rule. And the rule is what we're going to put in here. So we're going to say, for the nth term, for number n, how many squares will there be? So if we look at what we've got, we're going up in 2s. So the number of squares is going to be 2 times the number. So 2 times n. But that's not going to be quite right. We can see that because if I just double the number, 2 1s are 2. I'll do it in a different colour. 2 2s are 4. 2 3s are 6. And 2 4s are 8. So if the rule were just 2 times the number, we wouldn't get 3. We'd only get 2. And we wouldn't get 5. Right? We want to have 5 squares in the second one, but if my rule were 2n, I'd only have 4. So you can see that that's not right yet. What do I have to do to get the right number? Well, I've got 2 here, but I want to get 3. So I need to add 1 on. Let's see if that works. So let's try 2n plus 1. 2 plus 1 gives me 3. 4 plus 1 gives me 5, and so on. So that's going to be my rule. So we'll start out by writing it like this, but then we remember that in algebra we don't like the times sign. So my rule is s equals 2n plus 1. Okay, now let's look at where we can put that into this table. Sometimes we can put it up the top here, but sometimes we have to find it in the table. Right? So down here you can see that we've got this row here where it says n. And here we've got a gap, and that means we need to explain that the rule is 2n plus 1. The next thing we're going to do is we're going to figure out the other gaps in this table. So here we've got 11, right? And here we've got a gap. So what we're asked to figure out here is how many squares are in the 11th pattern number. So we'll go 2 times 11 plus 1. What we're doing when we do this is we're substituting in a value of the pattern number. So 2 times 11 plus 1 gives me 22 plus 1, which is 23. So we can fill in that box there. What about the 27th pattern number? Well, we take 27 and we substitute it into the rule. So 2 times 27 plus 1 will give me 54 plus 1, which is 55. So the 27th pattern will have 55 squares. Right, and again you can see the rule is just sitting here. This is the nth term in the pattern, the nth pattern, and this is how many squares, 2n plus 1. Okay, next one is the same idea. How many squares will the 100th pattern have? So we take 100 and we double it, 2 times 100, and then we have to add 1, and we get 201 squares. So we just write that in our table as 201. Now you can see how that's fitting in with our picture. If you go all the way back to the start, the plus 1 in my rule is that very first square. Right, so we've got one extra square here, and then we've just got our 2 times table. I put on a couple of harder questions as well. So what if we were asked, which pattern number will give me 49 squares? Remember, this column is the number of squares, this column is the pattern number. So this time we know that our rule goes like this. We've got S, the number of squares, is equal to 2n plus 1. Until now, we've been given a pattern number. But this time, we've been given the number of squares. So we're solving this equation. There are 49 squares. What is the value of n that's going to make that statement true? And we know how to solve these because we've just finished a whole lot of work on two-step equations. We take n off both sides, so subtract 1 from both sides. We get 48 equals 2n. Right, so take away 1 on both sides, and now we divide by 2. And we get 24 equals n. So that tells me that the 24th pattern will have 49 squares. So we'll fill that in there. And we've got one more of those to practice. Which pattern number will give me 501 squares? So we have 501 is equal to 2n plus 1. Subtracting, we get 500 is equal to 2n. And now we divide by 2. 250 is equal to n. Okay, so that's the first question done. I'm going to do a few more, but I'm going to go more quickly. So I'd like you to make sure that you've tried these with the video, so use the worksheet on Google Classroom and draw these patterns out in your book. I'm going to do the table down below, but let's look at the pattern first. This is pattern 1, and this has got 4 dots. This is pattern 2, and you can see that we started with my 4 dots, and then I've added on 3 more patterns. Sorry, 3 more dots. So it looks like we're going up in 3s, right? And here, what have we got already? Well, we've got this. Let's see if I can draw, and then we've added on this dot, and this dot. So that's going to have 10. So the common difference here is 3. We're going up in 3s. The 4th pattern will have 13, right? 4, 7, 10, and 13, and then 16. Now, I like doing my tables working down the page better, so I'm actually going to redo this one, and then we're going to find out a few extra bits. Okay, so here's my table. Messy table, but hopefully that's okay. So here's N, and here's D. So the first pattern, 4 dots. Second pattern, 7 dots. Third pattern, 10 dots. Right, what are we asked in this worksheet? Well, we have to find how many dots are in the 30th pattern and in the 54th. So to do that, we need to work out the rule. And then once we've got the rule, we can write it into the table. So here we're going to have n, and next to it we're going to have the rule. Now we're going up in threes, so that means my rule will be something to do with the 3 times table. Every time I go up, I'm increasing by 3 dots. So let's try out that rule. 3 times n. 3 times 1 is 3. 3 times 2 is 6. Let's just get rid of that there. 3 times 3 is 9. So it's not quite working, right? I've got 3, but I want to get 4. I've got 6, but I want to get 7. So if we had instead 3 times 1 plus 1, that would work. That would give me 4. 3 times 2, 6, plus 1, 7. 3 times 3 plus 1, 10. So my rule is going to be 3n plus 1. Now there's another cool way to do this once you get used to it. You can see here that I'm going up by 3 each time. So you can think of the rule as fitting what we've learnt about linear graphs, right? And so if this n were 0, how many dots would we have? Sometimes you can see that in the structure of what we've got here. So looking at these patterns, you can see that every time we're going up by 3 dots. Right, so there's 3 dots there that are new. These 3 dots here build on that one, and then these 3 dots here are new. And sitting here in the middle is that 1, and that's why we've got a plus 1 in my rule. So some of you will be able to see the plus or minus number, which we call the intercept, from looking hard at the picture. But there's another way to do it. Here we've gone up 3, up 3. But we could go back 3 here. So we've got 10 going down in 3s now. 10, 7, 4, and then back here to 1. And that number is what the plus 1 is doing in there. Okay, how many dots in the 30th pattern? We need to use the rule. The rule is 3n plus 1. And here, n is 30. So it's 3 times 30 plus 1 gives me 91. So there are 91 dots. And we could put that into our table as 30 here and 91 here. How many dots in the 54th pattern? 3 times 54 plus 1 gives us 163 dots. So we could write that in like that. Okay, I think we've got time for one more. I'm going to do this one really fast. So if you count these up, you'll see that we've got, in the pattern numbers, we've got bricks, we've got 5, 9, 13, 17 and 21. So it's going up in 4s. So my rule is going to be this. We're going to have n here and b here. So when I've got the nth term, b will equal 4n, right, my 4 times table. But look at what's happening here. 4 ones are 4, but I want to get 5. I need to add on 1 again. Now it just turns out that it's adding on 1 in all of these. It's not always. Let's check that. 4 2s give me 8, but I need 9, so add 1. 4 3s give me 12. 12 plus 1 is 13. So there's my rule for that one. And you can work out these ones, and the answers are on Google Classroom. The last pattern in the worksheet, we're looking at the white tiles in this pattern. So we have to count quite carefully. So I've done the first two for you. We've got 8 white tiles here, and we've got 12 here. So we need to count here, but we're going to have 16. So we've got 5 white tiles there. This is how I saw it. 5 here, so that's 10. And then we've got 2 lots of 3. So 10 plus 6 gives me 16 here. And then we're going up in 4s. So my rule is going to be something with 4n. It's going to be w is equal to 4n. What are 4 ones? 4 ones are 4, but I need 8. So I need to add 4. Now we can test that out. 4 2s are 8, but we need to add 4. So that looks good. Okay, thanks for watching. Very long video, but hopefully that helps you understand how we find the rule for a pattern.